Every year, vast container ships like this make over 100,000 journeys across the world's oceans, transporting over 2,500 containers every trip, packed with everything from bananas to motorbikes. But in order to make a monstrous ship like this move, they need to build an equally monstrous engine. So, how do they do it? Kiel in Germany, and a brand new container ship, the Auckland, is nearing completion. Over 210 metres long and weighing 34,000 tonnes, this massive vessel will circle the globe for the next 30 years. But right now, it's going absolutely nowhere, because it doesn't have an engine. That engine is 1,500 kilometres away in Croatia. And here is the beast. Over 10 metres long, 6 metres high, and weighing in at a mighty 640 tonnes, this thing is the size of a house. And although it might look like an overgrown car engine, there any similarities end. Because when it's finished, this monster will be able to generate an incredible 29,000 horsepower. Putting an engine like this together requires 50,000 hours of hard labour. So the team of 400 men are bashing, screwing and welding like the clappers to try and meet the shipbuilder's deadline. Unlike a typical saloon car, which uses 4 cylinders with a capacity of 1.5 litres, this monster will use 7 cylinders and has a total capacity of 7,500 litres. So it's probably best if we don't even consider the fuel bill. First, they need to create all of the parts. No mean task when you consider there are 10,000 of them. Most of the major components start life here, in the patent room. The process begins by making precise wooden moulds for each of the different components. This one will become one of the cylinders. These moulds are then transferred to the foundry, where castings are produced from molten iron heated to 1,350 degrees. Each of these buckets contains 5 tons of the stuff, so it's probably not a good idea to stand too close. Just as well they're wearing fireproof clothing. Whilst the larger components are fabricated from wooden moulds, other parts are cut from sheet metal, using computer programmable cutters, or even by hand. These smaller pieces are then welded together. Every part has to be precision manufactured, as unlike a standard petrol engine, which uses a spark plug to ignite its fuel, diesel is ignited by pressure in the cylinder. With an engine as massive as this, that means the components will be subjected to incredible stress. As the huge parts are laid out, the full scale of the assembly task ahead becomes clear. Just like building a house, the engine is built from the bottom up, so the first part on the floor is the bed plate. The problem is, when you have to shift components as big as these, you need some serious lifting gear. So the factory uses 60 125-ton cranes. These monster lifting machines are remote controlled and move on a network of rails. With the bed plate in place, it's time to install the massive crankshaft, which will be driven by the huge 72-centimetre pistons. Then comes the 65,000-kilo engine gasket, which is carefully lowered into place and bolted down. It takes over 50 days to complete the assembly, but just one slight delay can ruin the carefully planned schedule, so the pressure's really on. Eventually, after 55,000 hours of work, they're ready to test the engine. It's a tense time. What they're waiting for is the sound of 30,000 horsepower. Yes, it's a thumbs up all round. Bang on schedule, this $6 million engine is complete. Now comes the tricky bit. Somehow they've got to get this 640-ton mass of steel out of the factory and all the way to Germany. It's a major lifting process, requiring their heaviest cranes and a pile of tough steel cables. With a creak of cables, the engine is gradually hoisted from the floor and creeps slowly forward out of the factory toward the ship, which will take it on a 6,000-kilometre journey to Kiel. 2 hours later, it's finally lowered onto the deck and secured. 3 weeks later, the engine arrives at its destination. Now begins the toughest part of the whole process. First, they must crane the massive engine from the deck of the delivery ship and then swing it over the deck of the waiting Auckland. It's a major operation, requiring a 900-ton crane and 12 men. They have to somehow maneuver the engine through an opening barely bigger than the engine itself, then lower it 12 meters down into the engine room and line it up perfectly with the ship's propeller shaft. It's a slow and tense procedure. With this much weight testing the lifting gear to the limits, one false move could cause a catastrophe. Finally, after several hours, the engine gently settles onto its mounting brackets and is bolted securely into place. Over the next few days, it will be fully installed and connected to the main shaft that will drive the ship's 7-metre-wide propeller. This engine will power the Auckland across the ocean 6,000 hours a year for the next 30 years, guzzling over 300 gallons of diesel every hour. But without this monstrous motor, the Auckland and its precious cargo would be going nowhere.